Hello, calculus fans. Let's use a change of variables. The one we'll use is x equals u squared minus v squared, y equals 2uv, to evaluate the integral of y over the region R, where R is bounded by the x-axis and the parabolas y squared equals 4 minus x squared and y squared equals 4 plus x squared. And we want y to be bigger than or equal to 0. This is actually the same region that we talked about earlier. So the region R looks like this guy. We're going to create a transformation from the region S into the region R and use that to help us evaluate the integral. Now we previously computed that T of S is equal to R, where S is just the square 0, 1 cross 0, 1. The reason that we're going to do this change of variables is that S is a really simple region, much simpler than R. First, we need the Jacobian. So we compute all the partial derivatives of x and y, put it in a matrix, and compute the determinant, and we'll get 4u squared plus 4v squared. Now the Jacobian is positive, except at u equals 0 and v equals 0. If you'll recall, the change of variables theorem requires that the Jacobian be non-zero, but in general it's going to be okay if the Jacobian is 0 at a single point. Let's now use the change of variables theorem to evaluate the integral. So the integral with respect to x and y is hard. The integral with respect to u and v, much easier. So once we convert everything from x's and y's into u's and v's, we get this very simple integral. Integral from 0 to 1 of the integral from 0 to 1 of 2uv times 4u squared plus 4v squared du dv. By the way, where did this come from, 2uv? That's just y. If you go back and look at the substitution, that's where we get that. This becomes a fairly straightforward integral to do. We just have to integrate polynomials. So when we're done, we end up with 2 as our answer. Notice that the integral that we actually ended up evaluating was really very simple. The other one was going to be a lot more complicated. Okay, that's all for now.